ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Show that ABCD is a square and diagonal BD bisects angle B and as well as angle D. So again, you have to figure out what is the property of a rectangle and how is it different from that of a square. So how can we prove that rectangle is a square? That's the basic question. If you know the property, then you are done. If not, you can't do. Okay. So again, I'll give you guys a diagram, which is a simple diagram. You guys know how square looks. So figure out how is it different from a square. If you want to draw, you can draw a square next to this and see the difference. Okay, so we have ABCD, a rectangle. Yes, I have drawn a square, but it's a rectangle to begin with. So what and all properties we can tell? Well, we have the opposite sides which are equal. Then the angles are 90. Then opposite sides are parallel. Then the diagonals are equal and they bisect each other. So I'll do the diagonals later as and when I require. So these are all the things that we can conclude. So we have been given ABCD is a rectangle, right? So there are quite a few properties. We'll see that later. In which diagonal AC, okay, they given this. This is very particular. So this is important. Diagonal AC bisects angle A, comma angle C. Right? So not F, actually, we know that angle A and angle C are 90 degree. So as angle A, which is equal to angle C, both of them are equal to 90 degree. This implies angle DAC, which is equal to angle CAB, which is in turn is equal to angle DCA, which in turn is equal to angle ACB. So I'm talking about first, second, third and fourth. All of them are equal to 90 by 2 because it's bisected. So basically they are equal to 45 degree. Okay. So this is important to understand that angle 1, 2, 3 and 4, all of these are 45 degrees. Okay. So how does this help? Now think. So we need to prove ABCD is a square and that BD bisects angle B and angle D. Okay, so think about how do we go about doing the first part. Okay, I'll give you guys the first clue. In a square, all the sides are equal. Right? So if I prove that all the sides are equal, we are done. Are you able to figure it out? How? In triangle, say ABC, AB is equal to BC. Reason? Angles, sides opposite to equal angles are equal. So we are done. So since you have your adjacent sides to be equal, as the adjacent sides of a rectangle are equal, this implies ABCD is a square. So the first part is done. Next is to prove that BD bisects angle B and angle D. Okay, so for that you guys can draw one more diagram, another square. I'll do it here itself. So remember, we already proved that this is a square, right? Previously. So we can make use of this. So previous part of the same part of the answer can be used. So we have proved that all the sides are equal. And we know that these angles are 90 degree. Okay, so, and this is also 90. This is also 90. Okay, how do we do this? Well, we know that, since we have this to be 90 and these two sides are equal, so this angle is A and this also is A. So A and 90, they should add up to 180. So we can do it that way. So this is what I'm thinking of. Pretty much end up with the same thing actually. Okay, I think I'm trying to figure out which is the shortest version. Like if you take this two to be parallel and go over proving that all of this is 45 degree. Should we do that all of these angles are AA? Okay, anyways, if you are able to find a shorter version, please do that. So this is my answer as of now. In triangle ABD, right? So we have angle ABD is equal to angle ADB. Reason? What is the reason? Angles opposite to equal sides, that is AB is equal to AD. So we have this. Then we have angle A plus angle ABD plus angle ADB, which is equal to 180 degree. So if I happen to consider, let angle ABD is equal, which is equal to ADB, let them be equal to some value A. So we have this to be 90 degree, right? So this is 90, we already know that. 90 degree plus this is A and this is A, which is equal to 180 degree, right? So why 90 degree? Okay, we'll write the reason why this is 90 degree. Okay, here also we have used it. We already written the reason. Angle P, okay, we have written it. Right, angle A is equal to 90 degree. We have written in the given. That's the point of writing given in an elaborate way. We'll start off with ABCD is a rectangle, so all of this conclusion can be made. Okay, so 2A, if I transpose this 90, or I can do one more best thing, subtract 90 both the sides. So this will be 90 and then divide by 2. So this will be 45 degree. So this is 45, this is 45, and we can prove that this and this are to 45 as well, and we are done, right? So I feel this is a bit lengthy. Maybe I feel there's a shorter version out there. If you're able to figure out a shorter version, please go with that. If not, yeah, as of now, this is what I can think of. So angle ADB is equal to angle DBC, which is equal to 45. They are alternative interior angles. Okay, and similarly, these two particular angles, ABD, angle ABD is equal to angle BDC. Those two are to 45 degree. Same reason, and thus BD bisects angle B and angle D. Okay, so we have proved both of this. Yeah, that's it.